So, wir können vielleicht mit einer kleinen Ja-Nein-Fragerunde anfangen.
Maybe we can start off by a yes-no question. Many of you have access on vehicles, test vehicles, vehicles that have big computers in the trunk. We know algorithms that are nowadays already still too expensive for standard equipment. And you also know your competition. So today's state of the art, would you entrust your life to today's state of the art? So in terms of what's on the road today, do you know the systems well enough to decide whether you would entrust them with your life? Well, there are very safe vehicles for limited situations. For example, S-Class has these traffic jam function, and I think so far there hasn't been a greater problem with them. So some of these autonomous driving systems can do a much better job than humans can do in limited situations. So yes and no. Well, I agree. Things that are on the road today as equipment of standard vehicles is safe, and it is made safe and validated during development. We've not seen negative feedback. These driver assistance systems that have been on the road so far, traffic jam assist and so on, they are working very well. It's up to me now. It would be boring if everybody said yes. I'm a bit more skeptical. I wouldn't entrust my life to an end-to-end machine learning system today. I wouldn't go at 200 kilometers per hour with such a future system. Not today. No, I wouldn't. Well, end-to-end system is these are the ultimate black boxes. All sensor data will be entered, and the steering angle, the accelerator, and the lateral and longitudinal signal just are the output, and the rest of it is a black box. And the driver assistance system, I actually trust the ACC. The ACC system does a wonderful job in slowing down the car when I approach the car ahead. What about level 4, level 3 plus? You can just open your laptop and work while you're driving. Are there actually people who already do that? And I would say no. No? Well, let me say, I better say no now. Anybody in the audience who's ever been in such a vehicle, maybe on a test track, and where you said, yes, that was great, I'll do that again, no problem. Nobody here in this audience, so that's rather interesting. Well, then let's talk about what's missing. We've got powerful systems. We've got a lot of computing power already in the trunk, maybe not a standard ECU, but what's missing? What's there before we can have highly automated driving? Well, apart from some technical challenges that we need to master, is the possibility of mastering all the situations. What's missing is the validation concept. How can I actually make 100% sure that a vehicle works everywhere in the world, in every situation, as good as a human being? Mr. Schmidhuber, well, what will happen in the future? In the future, there will be so much experience with self-driving vehicles that we can say, well, on average, they are 10 or 100 times safer than human drivers. We're not there yet, but this will be a point that we will reach sooner or later. So what will happen? The legislator will be under pressure to create some kind of legislation which makes it mandatory. Maybe there will be situations where human drivers will then still be allowed. Well, why? Because it might be conducive to society. We live in a comparable situation because the German society has already accepted more or less that the valuable concept of traffic, well, we pay it with a death toll of 10 per day. So 80 million people, well, 10 people dying in traffic every day. Well, if we could reduce this to just one person dying per day or a 10th person dying, then I think the benefits are clear on our table. Maybe in one of these situations, the human being would have responded better than the self-driving system. And what happens then? Who will pay for that? You know, it's just the way we deal with it today. There is some kind of regulation or legislation which will make sure that the producer of the vehicle goes bankrupt, the vehicle which causes the accident, or the insurance company that has got to pay for it. So there would then be some kind of regulation which will govern that situation. Well, I think it's quite ambitious to say that these systems will become safer than human beings. Well, we've seen studies at Bosch where we tried to find out whether we'll ever reach that point, because the classic driver assistance systems are also being developed. Let's say the systems from the E-Class, from the S-Class, they are already in a position to reduce danger and risk in a lot of traffic and accident situations. So maybe, the question is whether assistance systems are able to reduce the consequences of accidents, reduce the risk of accidents. So the challenges for the automatic systems will be higher and higher, and then you might say, well, it's just a convenience function. Well, to the extent that the algorithms become more reliable, the automotive manufacturers will start to create systems such that the risk of an accident is reduced as far as possible. Well, today we have systems that learn, and then that don't learn, and add to them systems that are capable of learning. And this might have worked well over 100,000 kilometers. And I think we will then at some point heading to a situation where we can sell this to customers and they feel safe with it. So, how the percentage of the self-learning parts and how many things do no longer change once you've sold them, it's a difficult question. It's a difficult question to answer. I think what's critical from my point of view is the extent to which the public will apologize or will accept what happens with these automated systems. So maybe then the legislator will turn this into a law, or there will be self-learning things which are not a commodity on the road. What happens if there is an accident then, if an accident actually happens? I personally was uncertain what would happen after the Tesla accident, or what would happen if an OEM or if we do level 4, level 5 driving and the first accident happens. So, what will happen in the public no matter how much AI contributed to the accident? What is your feeling? Are we as society ready to accept it, should be more courageous in bringing these things to the road? Well, my personal opinion is, if customers, if drivers, if we recognize what the added value would be, we spend a lot of time in traffic jams, we could use the time more productively, and maybe reducing the number of people dying in traffic, but my personal benefit of a self-driving car, then I think it will be a question of time that the society will start rethinking, changing an attitude, changing a mindset. Maybe then insurances will become so expensive. Let's say for a conventional car, your insurance will cost 5 as much as for the AD system or for your AD car. So then the most important factor will be the economic factor. I think this change will happen. The question is when it will happen. and I'm not in a position to give you a point in time.
Okay. Sie hatten es eben schon angesprochen, die Absicherung.
Now, you talked about the validation of these systems and that this is a challenge.
Verkauft haben.
Regarding the systems that Bosch or other suppliers have sold so far, these are highly developed processes with, it needs a high level of confidence to make sure that these systems work the way they're expected to work.
Auf der einen Seite hochentwickelt, weil man
On the one hand, they're highly developed because the problem space has been covered very well, it has been penetrated very well, and there's functions, and for every function you will find somebody who is able to document in the company why it has been set up like this. What if we get to a point where we stop understanding things? What will we do? Let us know a little bit. Give us a little insight into Bosch. Where do we stand that we accept that even if it is only partial or partially, that we will end up with black boxes? How do we deal with black boxes? How do the employees respond to that? Can you tell us a bit more about that? Well, you mentioned it earlier on. A big black box, one network that takes over everything. We heard it earlier on that this is not the way it will be implemented. So we will see partition systems, then signals that will be fused, and then, of course, we will find out where there are some segments or areas or partitions where we have to improve things, or where do we have redundant algorithms. And I think this is the key to validating automated driving or autonomous driving. Now, if I compare deep learning, people will always ask, well, how can I understand what's actually happening? So this is like classic image processing, a cascade which recognizes pedestrian boxes or vehicle boxes. So I just put in my knowledge, I look at the features, but it's a statistical process. You can pass a traffic sign 100 times or 1,000 times. You will have a better or a worse recognition rate. And deep learning works the same way. So I already have this problem in standard systems. They never give me a 100% performance in some detailed functionalities. So putting all this on a sensor or algorithms, using redundant algorithms, the sensor array, which, a whole group of sensors, the radar sensor, other sensors, giving me signals, giving me data. Well, in the whole thing of AI and machine learning, people always complain that they don't understand them. People are afraid. It's a black box. I entrust my life to such a box of data. So I believe we have made much more progress. We understand it very well. We don't understand everything in artificial intelligence. But do we have to understand every single technical system? We haven't understood the human brain completely. Well, let's look at other domains. In medical, in drugs, we know that drugs help and they improve the condition, but actually we haven't understood the mechanism to the full extent yet. So what do? People do their testing, their drug approval processes. That's what they invest a whole lot of money, millions, billions. And I believe when it comes to AI systems in the automotive industry, this is similar. We understand a lot. We don't understand everything, but the rest, whatever we don't understand, has to be validated by means of testing.
Wo geht da die Reise hin in den Methoden, in der Algorithmik?
Ja.
And what about the methods and algorithms and where we're headed? Well, what's working very well is pattern recognition, speech recognition, image recognition, video recognition. All these are passive methods. And even if you steer a vehicle based on these methods, it's actually mapped onto what humans do, and it depends on acceleration signals, steering signals, things like that. But what if the learning system learns without a teacher, learns to do things that it wasn't able to do before, like a little baby that doesn't get input from his or her parents? If they learn how to lift a glass, or they understand, well, it's painful if I bump against this cupboard or whatever. So it's not a system that tells you you've got to tense this muscle more and then you will be able to do it. We are talking about situations that are much easier than if you have these board games such as Go. And it doesn't work as well as we would like it, and it's not as commercial as the, for example, pattern or image recognition. And many professions will profoundly change once robots, just by talking to them or just by observing them, learn how to imitate complex processes, such as assembling a mobile phone. And then maybe by giving some kind of reward, by experimenting how they can do it much faster. So this will change our society very much. Why will this be the case? Well, a lot of profit that's made in artificial intelligence is in advertising. All the big companies in the Western world, Google, Facebook, Tencent, Alibaba, they use artificial intelligence in order to make a lot of money based on advertising. Advertising is only 1% of the gross world product. So manufacturing of things, that's 10, 15%, 15% in Germany, and all this will change profoundly to the extent that we are able to educate robots, train robots in such a way that they can learn like kids. That, I think, is where we're headed, and I don't think it will take very long, and that will change.
Also eigentlich ist es eine gute Vorlage, weil Sie sagen.
Well, I think it leads us somewhere, at least, because you say just by using the tools we are using, we can solve problems and lead to self-learning, and we feel it already in the way how we are designing, developing. These are changing. The methods are changing, and maybe we should talk about the transition in the way we are designing and developing, where we have more requirement trees. Automotive industry is used to it, and also to secure processes that come from the cascade side, specifications, and so they don't work this way anymore like they used to. They are willing to go into another form of cooperation with the customers. And where do you see our development organizations in this? How far away are we from this revolution that is coming upon us, that may bypass us if somebody else is using this more efficiently than we are actually doing? So where are we positioned here? So give us your subjective feeling. Well, I think this is independent of artificial intelligence. What is also independent of it are the requirements that we have in automotive, in driver assistance, and so on. But everything is so volatile that it is not standardized or fixed in any way, that we have our development people in agile teams and not in cascading methods. So how do we get most of the value for our customer? That is the essence. And it is difficult to meet established qualification processes in this way, but we need it because, after all, we want to sell a safe product. The other thing is, what kind of talent do we need? There is a change which we feel, and we are moving away from specialized engineers into other experts who understand deep learning data. The domain knowledge is not of such a priority, but how can I apply to a system different issues, different problems? And the experts have to learn to apply it in the automotive field, then in a safe way. What I'm seeing in my daily work, when I started machine learning to do it, to apply it, and the process applied took 3 months of programming. Today, the cycle time is quite different. World-leading teams publish algorithms, they are made available in open source platforms, and everyone, the whole world, can use the algorithms, and within weeks, industry can then evaluate the processes and then convert it into products or implement it in products. It's quite a different timing and cycling and than it used to be in former times, driven by big data, data management. In both speakers, both keynote speakers, made it quite clear that for us, for the system supplier, for the automotive manufacturers, of the essence are data, and computer scientists are dealing with data, and they maybe have a different perspectives than an automotive engineer or a mechatronic engineer. Now, you said the speed, how quickly new algorithms developed at universities are invented. How quickly do we get them into series? There is a change of paradigm, and we will feel it at Bosch. Bosch has a big development and design sector, and in classical subjects, it was like this. Research went into something, developed something, and 5-10 years later, this was then going to the market in a product. And now, when we are talking about deep learning, about driver assistance, it doesn't work that way anymore. Just like you said, the approach freshly detected somewhere has to be brought into series in order to have an edge over our competitor. And in collaboration with our development, they don't develop something upstream, which we then pick up, and years later we realize it, but we work in pilot projects at the very beginning. So it is a clear change compared to 10 years ago. What would you say is the share of these deep learning methods in driving functions? Do you have a good feeling where it works and where it doesn't? Or could it be that as the German automotive industry, we are using only a very small part of the potential? Well, we are way up in front. Clear answer. Yeah. And many believe that that the automated driving has been invented somewhere else, but it comes from southern Germany. At ETAS, practically everybody knows that fact, but in Germany they don't. A German journalist does a research on self-driving cars, and then he starts to Google it, and then he ends up to a Google blog in California, and so he thinks that this was invented by Google. But it was Mr. Dickmanns in the 80s in Bavaria with the S-Class for Mercedes delivery vans, because the computers were so expensive that they didn't fit into a small passenger car. And then 1994, he drove in traffic, in the public traffic, Uwe Franzer of Mercedes and his team. So this all happened first in Germany. And what many don't know And maybe a reaction to what Mr. Ulmer just mentioned about the free available algorithms that can be applied so quickly. German industry took out patents, and more than 50% of all the patents in self-driving cars are owned by German companies. Google is owning only a small percentage, so the German companies are quite quick about it. And those on the Pacific Rim, they are not having any edge over us.
Schmidt-Huber, was Ihrer Disziplin Flügel verliehen hat, war der Überfluss an Rechenkapazität, der heutzutage zur Verfügung steht.
When you took off with many of your ideas, it was the excess of computing capacity, wasn't it? Yes, it was possible to bring many functions into applicability. So we generate computing resources. We have more and more powerful applications. But in the hardware, where would you like to put on your chips? Is it depending completely on computer performance, or do you say we have to invest into dedicated silicon, as it were? Well, first let me say, excess capacity. I don't think we can talk about excess capacity. We can only talk about less serious scarcity in computing time, so that things are working now. But especially for the video analysis, we need more computing time than we now have available. Unfortunately, every 5 years we get the factor of 10. Computing becomes cheaper by a factor of 10. And this law, I think since 1941, it applies. And the Moore's law. And it is, of course, limited by what is physically possible. And how do you compute in this universe? You need a 3D processor where small processes are compiled in a small space, which are all connected with short wires and a few long wires, so that those that are neighbors and want to exchange information, that they can do it in an economic way and energy efficiency, not like the GPUs which we have in the lab. There are small stoves, furnaces, as it were, and we cannot install them into self-driving cars. So the future hardware will look a little like this appears. Small processors connected by short wires, few long wires. And the physical limits are a long way from what we know today. So if the factor 10 applies every 5 years, so the SUSE could do one computation per second. One computation per second, and every 5 years, so it has become 10 times cheaper and 10 times faster. So we have 1 million, 1 billion at the same price. And if it goes on like that, and this trend isn't broken, then up to the next century, we'll need up to the next century to come to the physical limit, because they are 10 to the 51st per kilo of matter. To understand 10 to the 51st, what can a human brain, what can they compute? Well, the human brain can do more in an optimistic estimate, 10 to the 20th per second, maybe less, otherwise my brain would explode. But 10 billion people can then do 10 to the 30th. So 1 kilo of matter, according to the Bohm law, can 10 to the 20th more than all the people together. So up to the next century, we have to go on this trend, factor 10 every 5 years, and then we will have good, superhuman good applications. long before we reach the limit, we will have a factor of 100 per 10 years to achieve. So it's not exactly an answer to your question, but it's very close, I think. To rely on the hardware accelerators we have in the future is, to my mind, it's not enough. I think in the machine learning environment and in the AI environment, new algorithms have to be designed. It took us 20 years from the end to the 90s until now that deep learning took off. And the small steps along the way, you call them the epsilons, backpropagation and mathematics, and then the GPUs have more computing power and the data solved our problems. Whether this will work into the future, I don't know. I would wish that in the AI we have a breakthrough which goes to unsupervised learning. 90% of all issues we are working on are supervised learning, input-output mapping. A bit of math, applied math, and then a lot of computing power, a bit of stratification, and then we identify patterns. But how does a human brain work? How does a child learn? That's what we talked about in the beginning. And there are new and promising ideas leading us on, but cannot yet be installed in a product that I trust my life to. Well, these ideas are not so new. Since the beginning of the 90s, we have built these systems with a certain curiosity, like babies who set targets for themselves and experiment, like babies, but also like scientists to find out how the world works with the incoming data and with unsupervised experiments. So since 1991, this is going on. There is a long series of papers on this subject, and this is escalating as well. But it hasn't come to a point that you can roll it out to 3 billion people. But the roots are in the last millennium. And a small application in automotive, our company Nascens has done an experiment with Audi last year. Maybe you're involved here as well. And it was about that without unsupervised learning, just by pain and reward to park. So it was the first time that these little cars have learned in complicated situations to slip into the parking slot without a teacher telling them how to do it, just by trial and error. And you don't want to do that in real life, of course, because there you will crash a few Audis in the course of it. But you start with simulation and then with toy Audis. But even now, it is basically possible with unsupervised reinforcement learning in a very real environment, just with raw vision and raw data input coming from the cameras. And we're going to see a lot in this respect. And the roots are in the last millennium as well. Right. Well, thank you very much for an excellent discussion.